Hey there, grade 3 teachers. Let's have a look at some ways you can connect computer science into your energy unit. So you already know that your computer science unit is all about creating sets of instructions. There's some stuff in there about examining a Canadian invention. We're really looking at the creativity that is behind engineering. So any opportunities that we have to talk to students about creativity in design, how humans have creatively solved problems or come up with new technologies or new things to help solve problems or deal with issues, we're going to be covering some of this computer science learning outcome. And some of your skills and procedures you're going to easily be able to incorporate into other subjects or into your daily routines. And some, of course, you will have to teach explicitly, like examining a Canadian invention, for example. So we know that the computer science curriculum, all the way from K through 6, looks at 3 overarching ideas. We are talking about computational thinking, the design thinking process, and creativity, and how it all connects into creating eventually computational artifacts where students are asked to develop something with code in grade 6. Starting out in grade 3 energy, let's have a look at first how we can just do some simple algorithm design. So your students are expected to understand the computational thinking process and what's involved. So it would be advantageous to be doing computational thinking or making connections to it whenever you can to help solidify that for your students, because it's a big complicated concept. So just looking at some of these skills and procedures that you have in your energy unit, we're looking at describing some things, and we're talking about comparing, and we're also talking about predicting. So these are some very concrete science concepts. We're talking about force. So here, let's just say we're talking about force specifically as it is push or pull. And now I have an opportunity to do some computational thinking and even some algorithm design with my students. So asking students to come up with an algorithm for what defines a push, you are going to be teaching them about force and also teaching them about algorithm design and computer sciences at the same time. And this would be a simple algorithm for students to write. If these conditions are met, then it is a push. If these conditions are met, then it is a pull. So we've covered this concept, and we've also written an algorithm that could be used by a machine or a human. Here, let's look further at designing algorithms and sets of instructions, because your students are asked to do this fairly specifically. So if we're looking at some more things about force, so we're really looking at the concept of push and pull here, and let's look at that through the lens of a tug of war. So if we have gone over with students what pull and push means, we could then have students create a set of instructions for how to play tug of war. And if we ask them to do that, they're going to be showing us what they know about the concept of force, as well as working with these computer science skills and procedures about creating sets of instructions that could be followed by a human or a machine. So it's nice that they can leave followed by a human in the grade 3 curriculum, because as we move up, students are expected to write a set of instructions for a machine. But they've given you the license here to always be able to connect computer science in anytime humans are following instructions too. So I can ask students just to write the instructions for our science project or our science lesson, and they would be actually doing computer science skills and procedures while they were doing that activity well. So same in this case, we can ask them to create a set of instructions for how to play tug of war, and we are going to be working through computer science as well as energy at the same time. And we can extend and say create a set of instructions for how to win tug of war, and they're going to show us an even deeper level of understanding of the notions of force, and also how to write and refine really good instructions as is expected in your computer science curriculum. Exploring simple machines gives you the opportunity to hit this computer science skill and procedure around examining a Canadian invention. So you could invite your students to do a project or to learn about the Canadarm and how important it is to space exploration and its involvement in future plans of space exploration. And you would be talking about simple machines and how they work. So we talk about the function of the Canadarm, and we're going to be hitting this energy skill and procedure, and then we're also going to be hitting all of these computer science ones by looking at some creative engineering that is strictly Canadian too. And moving further along, you could have your students do this Canadarm challenge, which would have them creating something new by combining, changing, or reapplying existing ideas. So they would be familiar with the Canadarm, and now we are trying to take that idea and create something that's similar in the classroom out of cardboard and cardboard tubes or whatever we have. We could also ask students to create a set of instructions for that thing, that so they build their lever, their arm, and then create a set of instructions so someone else could build this project. And we've brought in a whole bunch more of those computer science skills and procedures into this, while we're also exploring simple machines and designing a device that uses simple machines and being safe all at the same time too. So lots of ways to cover computer science along with energy, and your students can build a fun project too. When students are conducting investigations, they're exploring something, doing some type of an experiment or testing, we can connect this into the computer science. Again, ask them to come up with those instructions, write them down, tell you what the steps are in order, and we're doing that, creating a set of instructions. They happen to be working with someone else, they're collaborating, you could, ask them specifically to, is there another way that you could write those instructions? Could you do maybe written instructions and something with pictures, or could you do the steps in a different order and still achieve the same outcome? We're going to get deep understanding of these computer science skills and procedures, transferring it also into this other learning about energy. Can you write a set of instructions for this experiment we're doing? Can you work with a partner to figure out these two different ways? As it says here, just ways to connect in some computer science while we're also covering this content. Whatever the investigation around force and objects may be, if students are able to come up with those instructions, then they're also working this computer science. So you give students this end piece. This is what you need to be able to do. How are you going to get there? Have them work out the process, deep level understanding of those computer science outcomes around creating instructions. When we're asking students to look at First Nation, Métis, and Inuit perspectives, we're definitely asking them to empathize, to put themselves in someone else's shoes. What do you think it would have been like to only use these simple tools? So once upon a time, we didn't have all of the things that we have today. People built and made simple tools to meet their needs. And what do you think it would have been like to live with just these things? What do you think that we have today that started as these simple machines? So we can have some conversations, we can empathize with the First Nations, Métis, Inuit, we can empathize with people in the past that didn't have the technologies that we have today, and we can think about, creativity and design and look at how people have taken things from the past, made them better, or made something new out of someone else's design. And again, that's all in those computer science skills and procedures to be looking at, innovative thinking, identifying computational thinking. How do you think, these engineers solved this problem? What did they look at? What did they decide needed to happen to solve this problem? And just working through looking at different technologies, different inventions. You can definitely look at some Canadian inventions so that you're ticking off that one as well. But just having conversations about how do you think that creative thinking process came to be. So those are some ways you can connect computer science into your energy unit. I hope you enjoyed.